little bit more about the endocrine system, and then you guys are going to work on Lab 23. So, this anterior and posterior pituitary. This is how we have the connections to that hypothalamus. The anterior portion, we had the portal system. On our posterior portion, now note that they're trying to show you that we have our hypothalamus, the part that looks like a W. We have our anterior portion, and notice how they're trying to let you know that this one has that portal system, the connection to the capillary networks, and that this anterior portion is the cellular portion, okay? But now for this posterior portion. In the posterior portion, it is smaller, but this time it is based on nerves. This is going to be our neuroendocrine cells. So, note how they're trying to show us nerve cells, okay? Trying to show the cell bodies, the axons, the ends that are synapsing, okay? So, when we look at this, the hormones that are going to be in this posterior pituitary, they get made by what we call the neuroendocrine cells, because we're going to have the connections to these areas in the hypothalamus. There's only 2 hormones. Do you see how they're trying to show the the green and the blue? Okay? They're trying to show you I have an area in my hypothalamus for one of the hormones, and I've got an area in my hypothalamus for the second one. Because that's it. So, this area of my hypothalamus makes it to this area of the pituitary, this one to this area of the pituitary, and the infundibulum is where my axons pass. So these are going to be called the hypothalamo-hypophyseal tract. Do you remember how we had the tracts in the spinal cord, ascending and descending?
Yes.
Yeah. Okay. Well, this one's letting you know that we have, and the tracts were the axons. Okay, don't forget that the tract means axons. So this is where the axons are passing between the diencephalon area and my posterior pituitary. A major difference between the anterior and the posterior. The hormones of the posterior pituitary are stored. In other words, the product gets made and the posterior pituitary stores it. Anterior pituitary doesn't. It makes its products on demand. Mainly because it's got to be responsible for 7, where the posterior pituitary is only responsible for 2. So the anterior is cellular, based on that portal system for the blood. The posterior is nervous tissue and is based upon synapsings of those cells. and the use of the tracts, T-R-A-C-Ts. So if we have all of these hormones, did I say 7? 8. Sorry. Y'all can take me out back later. Okay, so 8, 2 in the posterior, 6 in the anterior. Okay. When we look at the hypothalamus, or is it 7 and 2? I'm sorry. I might have my numbers mixed up. Y'all just go with what I put up on the slide, because that is correct. So if we look at the area of my hypothalamus, the area of my W, okay? 8 hormones total are produced. 6 move to the anterior, 2 to the posterior. In the 6 from my, now note, my hypothalamus, because this is the area it's concerned with, okay? Of the 6, remember how I said we were going to get releasing, stimulating, inhibiting, that sort of thing? In the hypothalamus, we're going to have releasing and inhibiting. So that means my hypothalamus can give the order for something to be made, meaning released, or for something to not be made, which would be inhibiting. Does that make sense? So, releasing means that they are going to go and they're going to stimulate my anterior pituitary. Inhibiting says no. So we say that that suppresses the pituitary gland. This is a term of a chemical that you're going to hear about. Somatostatin. Okay, let's take our term apart. Soma, body, okay? Statin. Have y'all ever heard of that associated with anything? Cholesterol. Because people who have like high cholesterol, they're given a statin, all right? Like simvastatin. And the goal is to decrease or stop that production, okay? Somatostatin, well, this is basically, this is going to be one that's going to be associated with some areas of the digestive system. And the reason for that, when we eat our foodstuffs, the foodstuffs have to make their way to the digestive system, into the stomach, and into the other areas of the digestive system. And we have to be able to allow that food, those materials that we put in, time enough to go through the system so that we can get the nutrients that we have just taken in. When we eat, a lot of other things begin to happen in the body. Do you guys remember in part 1 when you talked about the gut-brain peptides, for example, like cholecystokinin and that sort of thing? Okay, all hormones, okay? Just the difference was they were simply just between the gut and the brain, okay? Now, somatostatin, this is a growth hormone inhibiting hormone. So what is it telling you that it's doing to the growth hormone?
It's stopping it.
Stopping it. It is also inhibiting secretion of my thyroid stimulating hormone. What do you know about your thyroid gland? What is, yeah, I'm sure you guys are familiar with your thyroid hormone, right? And you've probably heard of people might say something to the effect of, well, I've got hypothyroidism, or I've got hyperthyroidism. What are they telling you? How much TH, thyroid hormone. So either they're getting too much or too little. What kind of a physical effects do they have? Say, for example, if they're getting too little thyroid hormone, the hypo.
Isn't it weight related?
Weight gain, tend to be cold.
Heart palpitations, night sweats.
Heart palpitations, sluggish, Graves' disease. What about people who have hyperthyroidism? Weight loss, sweating, might be a little shaky, might lose their hair. What cells of the body is thyroid hormone affecting? What did we say about the cells of the body for growth hormone? Everything. Guess what? Everything but thyroid. So now I have something that's inhibiting my growth hormone, inhibiting the thyroid hormone. It inhibits my insulin and my glucagon. What are insulin and glucagon used for? Helps my sugar. In other words, the foodstuffs that I eat, that I either get the sugar to the cells that need it and use it, or I store it, okay? Somatostatin, when we eat, comes into play because it wants to slow down my gut activity after a meal so that I can make sure that I get all the nutrients possible. So for just a short amount of time, somatostatin is going to come into play after we eat, slow things down just a smidge, and then once we can get stuff moving into and through the intestines, then everything else will get to come back out and play and take it where it needs to go. So somatostatin is one that it is a little bit of a different hormone, and it's going to come into play in a couple of different systems. All right. Now, the remaining two hormones, that's where I got the 7 and the 9. Your textbook counts this as being by itself. All right. Okay. The remaining two, my oxytocin and anti-diuretic hormone. Anybody familiar with oxytocin? What does it do other than the uterine contractions at the time of birth being its biggest function? Believe it or not, plays a whole lot more roles. This is what we knew, okay, about oxytocin. It gets released at the time of giving birth so that the contractions get harder and stronger and longer, because believe it or not, the entire time the female has been pregnant, that baby has been a foreign object, and from day one the body has wanted to get rid of it. Now it gets its chance. All right, so it makes the uterine contraction stronger, longer, that sort of thing, so that and baby comes out. Anti-diuretic. Well, if you take a diuretic, what does it make you do? Go to the bathroom. Anti